This IPv6 header is a simplified header. We spoke about this earlier. Now this version field will be always 6 because it is IPv6. And the traffic class, which is also known as DSCP values, is for marking. Based on the marking, the preference prioritization will be done, which is called as QoS. And you see, this 8-bit is for the quality of service. And followed by, there is another 20 bits, which is a marking done to say that this is the packets of same flow. One conversation, one flow will have similar identification, flow label. And then we have payload length. Length of the payload in bytes. It will show how big is the total size of the packet. Not every packet will be of same size. If you do ping, ICMP will carry some payload and it will be small compared to the telnet that you do. You have 16 bits for the payload. Next header. This is going to tell whether the packet is TCP or UDP. Next header means what? The transport layer. This is network layer. Or if you're using OSPF, then it will show the next header is OSPF, not layer 4. OSPF works in layer 3. So what I'm trying to say is it will show you either the next layer, which is TCP or UDP, the transport layer. If it is layer 3 packets header, like OSPF, layer 3 protocol packet header, then it's going to show what protocol, whether it is EIGRP or OSPF. It'll mention. Wait, let me capture. We were talking about the next header. The next header will talk about the next layer or the protocol. You see, I have screenshots of both. This is talking about the next layer. What is next layer? TCP, transport layer. So the next header of IPv6 says TCP. Whereas the other screenshot, if you see, it says the next header is ESP because they have then VPN. ESP, encapsulating security payload. IPsec VPN. Did you understand next hop? Please respond. Did you understand next hop? Okay, in short, the next header is giving a clue, hint, what follows after this layer 3. After layer 3, sometimes it may be layer 4 protocol like TCP, or it may be like OSPF or EIGRP, or if it is IPsec protocol, IPsec VPN, then it will be ESP, encapsulation security payload. So right on layer 3 header itself, you get an idea. You see, this is layer 3 header. You see version, you see QoS, you see flow control or flow label, you see the payload length is 40, and the next header is TCP. Whereas on the other capture, you can see payload is bigger than the previous one, and the protocol header is ESP. See, the next header is what? ESP. So it is saying here itself in layer 3 itself what is going to be the next layer. Next layer is ESP, and that is this one. Did you understand? Instead of the word TTL, IPv6 header has got a new name, hop limit. Both are same actually. Both are same, 8-bit. And then the source IPv6 address is 128. Destination IPv6 address is also 128. Are you clear with this header? Are you clear with these headers? Now you see, this is the default headers, which is mandatory for any packet. But you can add more headers, sorry, more fields. Yeah, yes, sir. No, the whole packet. No, the whole packet. Yes. Now you see, these fields that you are seeing, 1, 2, 3, 4, 5, 6, 7, 8 fields. These 8 fields are mandatory fields. It will be always there. But there is an option to extend the IPv6 header according to the requirement. IPv6 supports extension. For example, if you are doing MPLS, are you listening? If you are doing MPLS, usually MPLS layer will be a separate layer in IPv4. Whereas in IPv6, you can embed the labels inside the layer 3 header itself. In service provider track, we learned this. Extension, depending on what service that you are enabling, that will be made automatically. That will be made. Fine. Now, if you talk about the address types, in IPv6 you have unicast. You know what is unicast? Multicast and anycast. Anycast may be new to some of you, but unicast and multicast is well-known story for you, right? What is unicast? That is written there. Tell me something else. You don't. No problem. Someone can try. Unicast. What is unicast address? The address of a particular device, isn't it? 10.0.0.1. Say unicast address in IPv4 10.0.0.1. Can this address point out two device or five device? No. It's the address of a particular computer, single device. Multicast means what? The address that identifies group of device, isn't it? That is multicast. Any cast, one to the closest. One to the closest. Any cast, I will explain you. But before that, are you clear with that unicast and multicast? Is there any confusion in that? No confusion, right? Any cast means the closest. I want you to remember this word, closest. Nearest. Any cast addresses are configured in multiple locations, but I'll be using the closest. For example, McDonald's, KFC, Burger King, Reliance Footwear, Reliance Digital, Carrefour. These malls, these shopping malls, you will see many in a city. To buy a shoe, I go to Reliance Footwear. You also go to Reliance Footwear. Both are Reliance Footwear, but you and I did not go to the same location. You went to the closest to your house, closest Reliance Footwear. I went to my closest Reliance Footwear. You see, the Reliance Footwear is like an address that can be repeated in different location. One address given to different device in different location, so that whichever is closest, people will use. For example, DNS. DNS server, everyone wants DNS server, right? To resolve the domain name into IP address. So you can give the entire world the same DNS address, like Burger King. Burger King is everywhere. If you ask Bala, he will say, yeah, it's there one near to my home. Big burger. So he also had burger. I also had burger from Burger King, but I went to the nearest Kotanur outlet in Bangalore. But Bala, where did you eat burger in Burger King? Which location? Huh? Ah, see, he gives different location name, but the shop name is same. Likewise, IP address is same for all DNS. DNS is an example I'm taking where you can use any cast. But the DNS to which I reach and DNS to which your computer reach are not the same, even though the address is same. Do you understand now this statement? In an address configured in multiple locations, do you understand this? An address configured in multiple locations. So that The closest location can be reached. Did you understand these three types? What about others? Hmm. Now you see, in the previous class I said IPv6 is 128 bit size. And it is broken into 8 groups, each group of 16 bit. In another word, each group of 4 byte, say 4 hexa, 4 hexabit, and they are separated by colon. And we also saw in hexa, when you write IPv6 address, it will be what? 32 hexabit. So 32 hexabit, if you make it as 4 in a group separated by a colon, how many will come? 8 times, right? 8. Now, when you have many leading zeros, you can eliminate. And if you have consecutive zeros, you can just put colon colon, but you should not do more than once. This is all we saw in the previous class. If you didn't understand this now, you can ask. If you don't understand this thing, you can ask now. All right, you understood. Fine. We also spoke about the subnet. Subnetting is easy. All that you need to do is add bits. Bits are reserved. Sorry, the 16 bits are waiting. You need to simply increment add values. We are not. Yes. See, there is nothing to learn in IPv6 subnetting. I am going to show you. Yes, for your answer is yes. You're going to learn, but it won't take 2 minutes. I was telling you in the previous class, whichever was difficult in the previous version, the newer version has made it easy. Only then it can be called as newer version, isn't it? If it is same complexity, complicated, then why you call it as newer version? Subnetting is very easy here in IPv6. I'm going to show you. In fact, the IPv6 that you're going to learn is the complete IPv6. It's not CCNA level or CCNP level, it is complete. So, are we going to learn in this course? Is a wrong question. We are going to learn complete. Subnetting in IPv6 is easy. It won't take much time. It's not like IPv4 subnetting. Now, we were talking about address type. Unicast, multicast, and anycast. Not only that, there is again another 3 classification: global unicast, local unicast, and multicast. You can compare this global unicast address to public IP address in IPv4. You can compare the global unicast address. For your understanding, I'm saying this. It is like a public IPv4 address. That's why you see that word global, public, unicast address. And these addresses will always start with 2000. All global unicast address will start with 2000. 2000 colon, go like that. It will always start with 2000 or 2001 or 2002 or 2003 like that. Likewise. The reason why it starts with 2000 is why it is not starting with 1. Why it starts with 2000? It is because in the year of 2000, IPv6 became standard. So for how many years this IPv6 is an industry standard now? Let's see who listening. 24 years, 6 months, 19 days. So the global unicast addresses are used for our communication. We ping with this address, we deliver packet with this address. We, the users, will be identifying device using global unicast address. Global unicast address is what we use. Now, there is another address called link local unicast. This is also unicast. But this is not the address that we will use for pinging or sending some files. It is only the global unicast address we will use for our communication. I told you global unicast address is like a public IP address. So you may have a question in your mind that is there any private IP address? In IPv4, we used to have private IP address. But in IPv6, in the beginning, they had something like private IP address. But it is deprecated. You see, the one with the star is what? Deprecated. FEC0 and FED0. There was one more also, they left it here. FED0. Both this FEC0 and FED0, they are site local unicast address like a private address, but it is deprecated, meaning what? It's cancelled. No more this reservation. This FEC0 is no more a site local address. There is no concept of private IP address in IPv6. So they removed it. There is no private IP address in IPv6. Hope you heard it. So they made it as deprecated. Why? Because they don't want anyone to be in private network. If you want to use the internet, which is a public network, you also be in public. That is what they are going to ask you in future. No private business. All should be visible in the network. So no private concept. Being in private is not really guaranteeing you security. Firewall, then why you have firewall? So what IPv6 is demanding from you is, if you want to use the public network, you also need to be in public. Otherwise, no, not allowed. Be in public and do whatever you want. We want to see who is doing to avoid threats to the government, to the society. So we want you who is doing this. That in that way they say this is more secure. Be in public, it's more secure for everyone. There is no private. Because private concept is there in IPv4, it is little difficult for the cyber security people to trace. Actually, we can trace, but little challenging. A dumb guy who has got the job in cybersecurity without proper learning, for him it is difficult to trace. An expert will easily trace, even if he is hiding behind 2-3 NAT. What I'm trying to say is, being in private is not going to be really safe for both user as well as for the internet. The firewalls, encryptions, those are all the one which can provide security. So if you are in private and if you say I'm safe, then don't buy firewalls. Every company, organization, member, the workers, employees, they're all in private only. And why they need firewall if they are safe? So being in private is not safe. You cannot say I'm safe because I'm in private. Global unicast address is meant for the users to communicate. Link local address is meant for the machines to discover each other. The protocols in the machines to discover each other. It is for neighbor discovery. So the other difference is the link local address is always starting with FE80. The link local address always starts with FE80 only, and then the global unicast address will start with this 2000. It may be 2001 or 2 or 3. Yeah? It's 2000 series. You cannot use link local address to ping. Why? In the routing table, you will not find the link local address as the destination network. You will only see the global unicast address as the destination network. Link local address is only to show who is next, the neighbor, not any final destination. More will be understood when we do a lab. As of now, you should know that there are two unicast address. Okiti, Ondu, one, Ondru, global unicast address. The other one is link local unicast address. Global unicast address are 2000 series used by the users to communicate. Link local addresses are used by the devices to discover neighbor. And they always start with FE80 only. That's the reservation done, FE80. Multicast address will always start with FF. You see, always start with FF. And the flag will be varying. We'll talk about the flag later. It will be mostly 0. For example, if it is OSPF, you will have multicast address FF02. Scope will be 2. 2 means a router, means between the routers to communicate, you need OSPF. Between the routers to distribute the routes, you need OSPF. So scope will be 2, FF02 : 5 is OSPF. FF02 : 9. Tell me, which protocol's multicast address is this? If this is OSPF, this one will be what? RIP protocol. For EIGRP, what will be the multicast address? 10 we don't write in IPv6. 10 is written as what? A. A means 10, right? In hexadecimal, A means 10. IPv6 is hexadecimal. Do you agree, sir? A is 10. Okay. That's about multicast. So we are going to talk about this special addresses EUS 64 in our next class.